In this lesson, we'll continue adding components. Our next component is the moving jaw. The vise contains two such components, so we'll add this part twice. Let's add the first moving jaw. Select the biomatings method. Let me adjust the additional window. The moving jaw should slide along the bronze plates. So we need to align the plate's upper face and the jaw's lower face. Let's ensure the jaw takes the correct position. It's OK. Confirm the mating creation. This hole should be concentric with the fork hole. Let's achieve this. Click Coaxial. Select the cylindrical faces. Confirm. If you look at the mating section, you'll see that the new mating has been created. But mistakes can occur sometimes. For example, if the jaw wasn't designed correctly and the hole was shifted, the system wouldn't be able to create the coaxial mating due to a conflict with the coincidence mating, and an error would appear in this field. Let's check how this error looks. I'll try to add an impossible mating. Now these matings are in conflict. I'll delete the wrong mating. In case of the shifted hole, you would need to correct the jaw geometry. Here all parts have correct geometry, so we can confirm the insertion. Don't stop the command, because we need to add another moving jaw. Click Biomating. Again, select the lower face of the jaw and the plate's face. Click Coincidence. Click Coaxial. Select the cylindrical faces of the jaw and the fork. Uncheck Reverse Orientation to rotate the jaw to the correct position. Confirm. Confirm again. Stop the command. Despite the matings, the jaws can still move along the whole axis. Let's look at this. Start the Move Components command and try to move the jaws. This is only possible along the axis of their holes. Alternatively, you may stop the command and try moving the components directly by holding the left mouse button. You'll get the same result. Let's add a symmetry mating to ensure symmetrical movement of the jaws. Start the command. First, select the symmetry plane. It will be the blue XY plane. I'll select it in the additional tree. Then, select the faces that should be symmetrical. Let's select this face and this face. The components have been moved symmetrically. Confirm. If you double-click the component in the tree, you'll see this symmetry mating in its mating section. Let's test how the symmetry mating works. Start the Move Components command and try moving one jaw. The second jaw moves symmetrically, exactly what we need to simulate the mechanism operation. We'll do this later by adding mechanical matings.